The Interested Reader podcast is about exploring the world beyond the textbook. We'll cover many lessons in math, physics, and astronomy, and then delve into the mysteries of the universe. Physics is fun, people just don't know it, and I want to change that. I want to spark your curiosity about the world around you and ignite your passion for exploring and questioning. I'm your host, Sarah Tyke. Come with me and let's take a random walk into the world reserved for the interested reader. Hi everyone, this is Sarah Tyke from the Interested Reader podcast. I know it's been a while since I've released a new episode. There've just been some things going on lately and I kind of got off track with the podcast, but I'm back now and I might be going a little bit different direction. I don't think I'm going to be doing the lessons quite the way I had originally planned on. This episode, I won't have a lesson at all. This is a continuation of episode 3 with the music of the spheres. But going forward, I think the lessons will still be there, but I think I'm basically going to go through kind of your standard physics textbook and teach the lessons that way. Just briefly, 5 to 7 minutes will just give an overview of the section or the chapter as presented in a just normal college level physics textbook. That is really the reason I wanted to start this podcast, was to teach physics and astronomy. So that's what those mini lessons are geared for. I think before I just didn't really have a plan of what I was doing. It was just going to be kind of haphazard and random. But that's just kind of confusing and doesn't work. Probably not for you guys, not for me. So starting the next episode will basically be covering the physics textbook that I used in college. And we'll just mini lessons, just kind of break it down. We'll get a little bit of physics, and then we'll try to go into more of the alternative theories, things you don't hear about in the textbook. But we will get a little bit of our textbook lessons, and then we'll go into the more fun stuff, I guess. So today is the continuation of Music of the Spheres. And last time we kind of talked about the history of the music of the spheres and how Pythagoras had quite a role in it, kind of putting forth this theory, and Johannes Kepler also developed this theory of music of the spheres. And obviously we can't really hear sounds of space because there's a vacuum and sound can't travel through that vacuum. So back in, the time of Johannes Kepler and Pythagoras, they couldn't have any way of putting sound to the universe. It was all just theory. It was all just what they imagined it would probably be like. But today we actually have a way to put sound to the images that we get from Hubble or the James Webb Space Telescope. And that method is called sonification. So this is where you take non-acoustic data, basically just a visual image, the brightness of a star, the distance from the center of the galaxy, and you turn that into an audible sound. So you can take any wave, you convert it to a sound wave, and you can scale it to an audible frequency. And they do this with pretty much any astronomical data, whether it's color, brightness, distance. I think they even use rotation speed. They can put sound to any of that. And what's pretty cool is they do this for blind people. Since they can't see the Hubble image, with sonification they can actually hear the image, which I think is really cool. So we're going to look at a few websites. Today's basically going to be just a bunch of examples because it's amazing, I think, that they do this. So there's a collaboration between the Chandra X-Ray Center and System Sounds. And last time we talked about System Sounds, this is Dr. Matt Russo and his group. Their website is system-sounds.com. So here we have their collaboration with the Chandra X-Ray Center. I'll put all these websites in the show notes, but it's Chandra, CHANDRA.SI.edu/sound. So here's their homepage, and it's a universe of sound, and you can have all these different astronomical bodies they've sonified. So I've pulled up a couple. The site was kind of slow to load on my computer, so I have a couple pulled up here. So the first one here is the Galactic Center. So this is the galactic of our the galactic center of our Milky Way. So there's a giant black hole at the center, and that is known as Sagittarius A. So if you ever hear anyone talk about that, it's if you look in the direction of the constellation Sagittarius, you are looking at the center of our galaxy. And so here is just an example of that sonification here. So this is what this group would say our galactic center sounds like. And if you're watching, you can see there's this white bar that kind of moves across the screen, and it's the amplitude, the volume of the sound is corresponding to the brightness of the stars in the picture. So that's just a view of the center of our galaxy and what this group would say is the sound of it. And of course, they have assigned the instruments to the stars. Another example here is SN 1987A, or Supernova 1987A. This is one of my favorites because this is actually the supernova that got me interested in astronomy. And it was in a biology textbook in high school. So I had already registered as a biology major at the University of Florida. So this was my last semester, my last month of high school before I was going to go to college. And we were covering, so one of the last chapters of our biology textbook, and there's this picture of the supernova, and it had to deal with the fact that all of the elements that we have in the universe that make up everything on Earth and make up everything in our solar system, it all comes from stars that have exploded, like this supernova 1987A. And I saw the picture of this thing, and I was just mesmerized by it. And my first thought was, I want to see one. And so I started thinking, can I be an astronomy major? Is that something that I can do? It never seemed like it. I'd never considered it. I had been interested in genetics and marine biology, and I was just set on doing something with life sciences. And I see this picture, and then I start thinking, maybe I could do astronomy, but it just didn't seem something that I could do. It was something that other people did, like smarter people, you know. And I was like, can people just major in astronomy? Is that a thing? Can you just go to college and anyone can be an astronomy major? It was just mind-blowing to me. So I was like, you know what? I'm going to give it a try. So I did, and a few stumbles here and there, but I made it through. But it's all because of this supernova. So the designation 1987A means it was discovered in 1987, and the A means it was the first supernova discovered of that year. Apparently they now shortened the name to SN 87A. So here is this guy. And they start in 2009 with the data collection. I believe they end in 2012. So let's take a listen here. So once again, they're kind of moving their data point around the circle of the supernova, where you have this large ring of gas and material. And as the image gets brighter, you'll hear the sounds. The pitches get louder and higher intensity, or higher pitch, higher frequency. It's a fairly short clip there. So all of the ones on this website, this one from the Chandra X-ray Center, are going to use the X-ray image and an optical image. Chandra is an X-ray telescope, so that was meant to capture data in the X-ray. So that's why this site will combine X-ray and optical for all of their sonifications. And one last one I liked This is one of my favorites, is called M104. It's also known as the Sombrero Galaxy. This is also one of my favorites because when I was in astronomy at the University of Florida, one of the courses we took was an optical astronomy course. So we'd actually go out and you use your almanac to find an object that you want to look at with a telescope, and you find out where it's going to be in the sky, on what day, on what time. And we went out to our observatory, and the goal was to actually plan where this object was going to be and take a picture of it. And it's a lot harder than it sounds. So me and my group, we were out there, we were looking for this thing, and every time you take a picture, so what you have to do is you have to take a long exposure picture. Because galaxies are so far away, you can't just take a snapshot. Oh, we didn't get it. Let's take another one. Take another one. You have to do exposure of 20 or 30 minutes sometimes. So you'll sit there and you'll wait and you'll collect data, and you'll be the camera's just collecting data. You're waiting, and then you can look at it and see if you got it. And most of the time we didn't, and we couldn't figure it out. We had the coordinates. We were aiming our telescope the right way. We couldn't figure it out. And it's getting light out because we had to do this overnight, obviously. So we were there overnight, and it's about time to go, and we're like, we're not getting it, I don't know. And so this one guy in our group's like, let me just try. He's like, I think maybe I see something, and I don't know that you can see M104 naked eye, but he just thought, you know what, last ditch effort, let's just try. There's kind of this fuzzy object that I think maybe could be something. So we put in the telescope, take our picture, and there it is. We got M104. And it was so exciting because you could actually tell that it was the Sombrero Galaxy. And our professor said that it was actually a very decent image, for what we had done, because we didn't have that much time to collect the data. So it was, not the greatest picture, but we got it at the last second. And I've always loved this galaxy. So here it is on the Chandra X-ray Center Sonification site. Let's just take a listen here. So again, if you're watching, you'll see this white line kind of come over the pictures. That kind of shows you the amplitude of the stars in the galaxy center as it goes over it. So there it went through the galaxy center, kind of wobbles a little. So if you're watching, the middle picture is the combined image of the X-ray and the optical. This is just the X-ray sound. And the first one we heard was just the optical data. And here they're just kind of going through it again. All of them together. So that was M104, the Sombrero Galaxy. So another place to go for sonification examples is NASA. And so they've done a bunch here. They have done a lot of the Hubble images. So they'll take elements like the brightness and the position of the stars, like we said earlier, and they assign pitches and volumes. And so they just take different instruments and they'll say, maybe just use a guitar. One of the examples is Pismis 24. So they're just taking a guitar, they assign the stars pitches based on how bright they are. So brighter stars are louder and higher pitched notes on a guitar. And then they'll also take the color channels from the image, the red, green, and blue color channels, and they map them onto low, medium, and high frequency ranges. And then they also take the pitch and map that to the direction that the star is from the center of either the galaxy or the star cluster. So a couple examples here. So this is the NASA sonification webpage. I'll put this in the show notes page as well. It's kind of a long website, but it's science.nasa.gov/mission/multimedia/sonifications. And this is their homepage here, Sonifications. So they have on the left side here, there's a whole bunch of different objects that they've sonified. So one of my favorites here is the Hubble Ultra Deep Field. So this one, what we're going to do is we're going to start at the most recent time, like current, and they're going to add stars to the image. And the farther away a star is, the older it is. So by the time we finish this little clip, we'll be looking back about 13 billion years, which is the age of the universe. So throughout this, you're just going to hear notes and stars being added to the image, which is, it's pretty cool. And let me just read here from their caption before we start. So the pitch of the note indicates the galaxy's color. So the lower notes are redder, the higher notes are bluer. And the color is from a redshift. So something has a very high redshift, it looks redder. It means it's farther away, it means it's older. The volume indicates the galaxy's apparent size. So if you don't know, the Hubble Ultra Deep Field is a bunch of galaxies. People have said it looks like a candy dish, and it kind of does. Okay, so then just under a minute, we can hear back nearly 13 billion years to the farthest galaxies. So here we go. Let's take a listen here. So again, as stars and galaxies get added, notes are being added to the sound. So we're at about 6 billion years, about halfway there. Here's 10 billion. We end at 13.35 billion years. So it's always been one of my favorite pictures too, just because it's iconic, and those are all galaxies in that picture. I mean, there's hundreds. I just think that's incredible. So again, here we are on the NASA site. We can see if there's any other interesting ones. Here's Supernova 1987A again. Let's see if there's anything else that I like. But yes, they got a bunch of different stuff that you can look at. Here's some twin galaxies here. This will be fairly short, it looks like. So this is just gonna go over two galaxies. There's one. There's the other. A lot of these things just sound kind of creepy, like they would be pretty good for, you know, Halloween sounds. So this is another one I like, the Pillars of Creation. This is also called the Eagle Nebula, or M16. This one also gets shown quite a bit in Hubble galleries because it is beautiful, and it is where star formation is taking place. If you're watching, what you'll see is these dark pillars of dust and gas. And in this particular region, you can see that there are stars being formed, and they're just condensing out of all this dust that's in this area, and it's been known as the birthplace of stars, why it's called Pillars of Creation, and it's just shown everywhere, and it's amazing. So let's take a listen to this. So here we're into one of the first pillars. Here's the second one. And that's the last one there. And then all the other little blips and beeps in the background are just stars you'll see in the background image. So anyways, those are some examples of sonification. And again, the last site that I wanted to look at, we addressed this in episode 3 too, is this system-sounds.com. So this is one of the first ones that I had seen. I think we played some of these last time. The TRAPPIST-1 system, which has a resonant frequency among all of its elements. There's the black hole, which is pretty creepy, again, for a Halloween soundtrack. That would be good. So, I mean, you can just go and explore these websites. Again, I'll put these 3 in the show notes. And I think there's just a lot that you can go out there and explore. Let's just see what this guy is. This 5,000 exoplanets. Watch and listen to the discovery of the first 5,000 exoplanets. I don't see a play button here, but it might just take a second to load. So anyway, so this is about all I really wanted to talk about as far as sonification goes, and the music of the spheres. Let's try this one here. This is the exoplanets. So each of those notes is a planet being discovered. We're up to year 2001, 40-ish planets discovered. 2004, we're over 100. 2009, we're in 300s. It's pretty fun to watch too if you get a chance to go to the website and actually watch this. So 2020, we're at 4,200. There we go. 2022. 5,005 exoplanets. Alright guys, that is it for the music of the spheres. I hope it wasn't too boring with just a bunch of sound clips, but I think it's just incredible that they've put sound to the universe, and it's just amazing to listen to it. And obviously it's, you know, not real. The universe doesn't sound like guitars and violins, but you know, it's as close as we're going to get. I think it's a good representation, and they're using actual data for it. So I think I just find it amazing, and I hope you guys got something out of it. I hope you enjoyed it. And if you'll join me again in 2 weeks for episode 5, we'll kind of get underway with some physics lessons and some other interesting topics. If you have any questions, you can email me at sarah@theinterestedreader.com. There's also a Facebook group. You can post questions there. I do my best to check and respond as I can there. I also had a newsletter. I haven't been doing that either, but I'll probably get back into that. We'll see. But also, if you go to the website, theinterestedreader.com. Again, I haven't been updating it, but I'm going to get back into that, so you can contact me there. There's a contact submission form. There's a couple different ways to reach out to me. So if you have any questions, if you have any ideas for topics you want to hear, let me know, and we will get into it. All right, thanks, guys. I will talk to you later. Bye. I hope you enjoyed this episode and are inspired to question and investigate the world around you. Let me know what you're thinking about. You can contact me through the website, theinterestedreader.com, send me an email at sarah@theinterestedreader.com, or join the Interested Reader group on Facebook. I'll see you at some later time T, where T is greater than T naught, and T naught is equal to now. Thanks for being an interested reader, and I'll see you next time.